Hello, everyone, and welcome. I wanted to do a video because I read through a lot of all of your um, discussion about choosing a quantitative data analytic technique. And I noticed there was quite a bit of confusion. And I think the reason for that is because our text lays out many possibilities for how for what techniques and procedures we can use to analyze quantitative data. However, I want to narrow things down and talk about how you make decisions about which basic quantitative data analytic technique to use. Okay, and this way, if you all are going to be doing a thesis or some other kind of capstone research project, or you're going to be doing something in your professional work, or you're going to be working with another researcher, you'll have a starting point for what a basic analytic technique you could use. Okay. So let's talk about making some decisions. And the way that we make the decisions is based on our research design and based on the our variables. So let's say you need to analyze some quantitative data, but either you haven't had a statistics class or you took one long ago and don't remember it. Your first step is going to be to calculate descriptive statistics for your sample. Usually, this is the mean and standard deviation for each of your groups if your sample includes groups. Then, if you want to make an inference to the population, you choose an inferential test or procedure based on your research design and based on the number and types of variables you have. Okay, so first, descriptive statistics. Many of the questions that we have, whether it's in education, in counseling, or in sports medicine, for example, can be answered with descriptive statistics if we're focused on answering them for our sample. And then, if we want to make a generalization to a population of individuals, then we definitely would need to use some inferential statistics. So let's see how we choose. So let's say we want to make some inferences to a larger population and we have a continuous outcome or continuous dependent variable. If we have two groups, then and a continuous dependent variable, if our independent variable is two groups, then we're going to do a t-test. And one of the nice things about t-tests is that you can actually do a t-test using Excel. Okay, it's a very basic um, analytical technique or procedure, and it is very widely used, and pretty well understood. So when we've been talking about samples, we've been talking about groups of people, but that's not entirely accurate. Samples are actually samples of scores, okay, or samples of values of a particular variable, right? And so um, one student was wondering, like, okay, if I give my class a pre-test and a post-test, isn't that just one group? Because it's they're all the same kids. Actually, it's two samples or two groups of scores. There's the pre-test group of scores and the post-test groups of scores. Now, yes, they are the same kids, and that's why we call it paired samples, okay? Because we took the same kids and we tested them twice. We have two samples from the same group of kids. And then we would do a paired sample t-test for a pre-post type of design. Now, if we have two groups and one group receives our intervention and one group doesn't, then that's an independent samples t-test. Now, these two analytic techniques are the most common in education. Okay. Now, let's say we have a continuous outcome again, and we have more than two groups. Maybe we have a high, a medium, and a low group, for example. The data analytic technique we would use is ANOVA. And ANOVA is the most common analytic technique in counseling and psychology. All right. So again, if we have, so now with here, the groups are one independent variable, right? Um, which group were they in? Did they receive the treatment or not? Are they high, medium, or low on some measure? Um, on some single measure, right? If you have many independent variables, then the most basic analysis you could do is a Pearson correlation, and that would generate a correlation matrix. And you could see how your dependent variable relates to your many independent variables. Now, another option is you can find someone with advanced statistics skills and ask them to do a linear regression. And so Pearson correlation is the most basic approach, and a linear regression is more advanced, but probably the most common, okay, when there are many independent variables. Okay, now what if we have a categorical outcome? And this is also a common situation. Did students graduate or not? Um, were the patients healed or not? Um, yes. Did the students with behavior problems get expelled or not? These categorical outcomes are a real possibility when you're in a professional setting. So categorical dependent variable, and if you have a categorical independent variable, you'd use what's called a chi-square analysis. Now, there's something called a contingency table. So if you're in this situation where you have a categorical outcome and a categorical predictor, or a categorical dependent variable, categorical independent variable, Google contingency table, because that's the most basic way of approaching it. Okay, and in Excel you can do something called making pivot tables, which is Excel's term for contingency tables. Okay, that's the most basic. Now, chi-square analysis tells you whether you can infer differences in your sample that you see on your contingency table to a larger population. Okay, that's what that does. Now, if you have a continuous independent variable and a categorical dependent variable, the most straightforward way of dealing with that is to make the independent variables categorical and then do a chi-square analysis. So let's say I'm looking at, does a person fall down a flight of stairs or not based on their age? And this comes to mind because I'm always worried about my preschooler falling down the stairs. Okay. So age is a continuous independent variable, right? Falling down the stairs or not is a categorical dependent variable. So I could do, like, are they age five or less, or age six or more? Divide the kids I'm looking at into two groups, right? The kids up to age 5 and the kids who are 6 or older, right? And so I've taken age, which is a continuous variable, and made it into groups. Okay, and then I can just do a chi-square analysis. Boom. Or I can find someone with advanced statistics skills to do what's called a logistic regression. And logistic regression is a way of inferring when you have a continuous independent variable and a categorical dependent variable. And it generates odds ratios, which was what was mentioned in your text. you can calculate odds and probabilities and odds ratios with a contingency table. But the odds ratios you get from logistic regression, you're able to apply to a population. Okay. All right. So now there's some situations where you have lots of dependent variables and independent variables. And you're not really interested in making that, you're not interested in making inferences to a larger population. So, for example, we talked about single subject research, and we have maybe one outcome, which is performance, right? That was the reading example. But we tested the kids' reading many times before we did the intervention, and then many times during the intervention, and then many times after the intervention was over, right? And so we're going to use descriptive statistics to compare the average performance of our students before the intervention, during the intervention, and after the intervention. Another time you're not necessarily making inferences is with survey design. So if you're looking at all the patients who attended a particular clinic over the past 5 years, and you want to describe their characteristics. Okay, how many of those patients were males? How many were females? How many were seniors? You want to describe their characteristics. Then you're just using descriptive statistics. You're not trying to infer anything to a larger population. If you want to make inferences, if you want to make inferences, and in particular your goal is to understand relationships among all of these dependent variables or dependent variables and independent variables, then you're going to do a Pearson correlation, and that will generate a correlation matrix where you can see what relates to what and how strong or weak that association is. If you want to make inferences, but your goal is to develop or test a scale or an inventory, and this is quite common in counseling and psychology, then what you're going to do is factor analysis. And there are a few different flavors of factor analysis. But factor analysis, it tends to be a more advanced technique. Okay. Usually, as practitioners, we're not necessarily developing new things. We're using existing tests, index, inventories, and then applying those results um, um, to some kind of decision making. Okay, but factor analysis is what you would use if you were developing or testing a scale or inventory. So, pop quiz. Which analysis for each research question? Okay, and I borrowed these from students' actual posts about their project. Okay, so first question: how does self-regulated learning, or SRL, impact our students' grit and motivation as demonstrated by pre and post survey collection? And let's imagine that the design of the study is all of the children at our middle school learned SRL. Okay? The clue here is the pre and post. Okay? You have two groups of scores. The group of scores from the students when they took it before the intervention, and the group of scores from the students when they took the survey after the intervention. That's two groups, a pre and a post. That means t-test. Okay? All right. Let's try another one. Is learning certain strategies associated with a higher percentage of students saying they are motivated? Okay, so this is in, kind of the same interest area, right? Motivation among middle schoolers. Let's say the design here, though, is that there are two middle school classes. One received the intervention, the other didn't. Okay, and then we see if the ones that learn these strategies, that receive the intervention, were more likely to say that they are motivated as compared to the students who didn't receive the intervention. Okay, so what analytic technique? Yep, Two middle school classes, that's two groups, very clear, that's t-test. Now the first one was paired sample t-test. The second one, independent samples t-test. Okay. All right. Third one, I should have numbered these. Among, let me fix that. Let me fix that. Number me. Okay. Number 3. Among adolescent cyberbully victims, how effective is a school based small group counseling curriculum in promoting higher self esteem, better coping strategies, and higher attendance when compared to individual counseling and no counseling? Okay. This one is a little trickier. Let's isolate those dependent variables first and then talk about the independent variables. Okay, so dependent variables or outcomes. We're looking at our outcomes that we're looking for are self-esteem, coping strategy, and attendance. And because this says higher self-esteem, better coping strategies, and higher attendance, I'm I'm assuming those are going to be measured. Um, those are going to be continuous measures. Okay, so we have 3 continuous outcomes. And let's see, what are our groups? Okay, these are all adolescents. These are all adolescent cyberbully victims. And let's see, but what happens to these kids? They get, some of them get small group counseling, some of them get individual counseling, and some of them get no counseling. Okay, so we have basically 3 groups. Our small group, our group of kids who got small group counseling, our group of kids that got individual counseling, our group of kids that got no counseling. So 3 groups. That's more than 2. Okay, and we have a continuous outcomes or continuous dependent variables. So that is ANOVA. Okay, ANOVA. 3 groups, more than 2 groups, ANOVA. If it's 2 groups, do the t-test. More than 2 groups, ANOVA. Okay. All right. Now, here's another cyberbullying question. Number 4. Do students experience cyberbullying as victims, perpetrators, or witnesses have lower school attendance rates than those who have no experience with cyberbullying, taking into account grade level? Okay, so what is our outcome or our dependent variable? It looks like this one we just have one. Oh, by the way, in number 3, you notice there were 3 dependent variables. ANOVA can handle that if you do something called multiple ANOVA or multivariate ANOVA, which is abbreviated MANOVA. But what researchers do is they just do a regular ANOVA and they just repeat it once for each of the outcomes. They do an ANOVA analysis for self-esteem, a second ANOVA analysis for coping strategies, and a third ANOVA analysis for, or what is called one-way ANOVA analysis for attendance. Okay, anyway, number 4 has just one outcome, attendance rates, and we're going to assume that is measured continuously. Okay. And students experiencing cyberbullying, let's assume they're in exclusive groups. They're either victims, perpetrators, or witnesses. Okay, so that is 1, 2, 3 groups. Again, our victims, our perpetrators, and our witnesses. And so we have 3 groups, so that means we can't do a t-test. We have to do ANOVA. But there's this taking into account grade level. Okay, so we actually have 2 variables. We have where were you in this whole bullying thing? Were you a victim, a perpetrator, or a witness? And then what's your grade level? Okay, so those are 2 independent variables. When you have more than one independent variable, then you would do linear regression, right? I put that. Or find someone who could do linear regression. Or you could do a Pearson correlation and examine a correlation matrix. That's a basic statistical approach. Okay, so number 5. Among patients receiving chiropractic care, are non parents more likely to reach their treatment goal than their parenting peers? So, yes, I threw my back out. And yes, I went to the chiropractor, and it turned out that there was a student working with my chiropractor who was majoring in kinesiology. And so that's why I put in this question. So we have patients receiving chiropractic care, and then we have non parents, and we have parents, and they and there's reaching their treatment goal is the outcome. So now reaching a treatment goal or reaching any goal, you either reach it or you don't, right? And so that is a categorical dependent variable. And then we have these two groups, non-parents and parents. Um, so we have a categorical outcome and a categorical predictor, a categorical dependent variable and a categorical independent variable. And that means you're going to do a chi-square analysis. Or you're going to make a contingency table first, or pivot table is what it's called in Excel. And that will allow you to do a chi-square analysis if you have the right software. Um, and I always found myself wondering about that because being a parent meant I had less time to go to the chiropractor, but at the same time, being a parent and having to lift my children over and over again made me want to go to the chiropractor so my back wouldn't hurt. Okay, so that's where that question came from. And question number 6. What are the relationships between the implementation of STEAM lessons and the following factors? Levels of professional development, level of motivation, accessibility of curricular resources, and availability of a teaching assistant. Right? So you can imagine that a bunch of science, technology, engineering, art, and math teachers were given a survey, right? And they were asked about the professional development they had received, about how motivated they were to do the lessons, about what curricular resources were available to them, and about whether there was a teaching assistant in the room while they were doing certain lessons. Okay, and then they were either observed or asked about their implementation of STEAM lessons. Okay, and so what analysis would we use to uh, address this research question? Okay, when I see a list like this, there are a lot of dependent or independent variables depending on how you look at it. Okay, there are a lot of variables here. Correlation, Pearson correlation is the most basic approach. Okay, and in terms of making inferences. Now, if you don't need to make inferences, you can do a contingency table. All right. Um, yeah. Let's see. Is there anything else to say about that? Oh, yes. Um, uh, maybe there's a scale you're developing to that you can use in future research, and maybe you're developing the STEAM implementation scale, okay, that you're going to use here in this study, but you're also going to use in the future as well. And then you would be doing some kind of analysis of the factors involved in order to make inferences about how well your scale is functioning. Okay? Does this make sense? All right. So I hope that was helpful, and I hope you have a great rest of the day. Bye bye.